Hi, question number 10. The linear transformation T, R to the 4 is represented by the matrix H, where H is equal to this 4x4 matrix. Find the dimension of the range space of T. It should have been saying, transformation T, but the matrix is H. Anyway, transformation T. Find, for the second part, a basis for the null space of T. And for the third part, it's given that x satisfies the equation hx is equal to 2 minus 10 minus 1 minus 15, using the fact that h times 1 minus 3, 1 minus 2 is equal to 2 minus 10 minus 1 minus 15. Find the least possible value of the modulus of the vector x. Also for the vector x, x1, x2, x3, x4, the modulus of x is going to be the square root of all the elements inside each one of them to the square. Now then, to be able to find the dimension of the range space of T, what we're going to do, we're going to reduce this into its row reduced echelon form, and this is the row reduced echelon form. And as you can see, the dimension is 3. We have 3 leading columns. These are pivots, 1 2 3, 1 2 3. So the dimension is 3. It's quite easy. Now you might probably wonder how I've been able to come up to that stage here by by performing the operation. So here's how I did it. Okay, now that was the original matrix, and remember, if you want to reduce it to the row echelon form, the idea is to turn all these elements into 0. So these 3 elements here, to make them 0, that's quite easy. 1 plus minus 1, so row 1 plus row 2, row 1 plus row 2, and you can see it's going to end up as 0. For this one, you see below 1 here, I'm going to turn all of that to zeros, and this is how I did it, all these operations. So 2 row 1 minus row 3, 2 times this row minus row 3, 2 times 1 is 2, minus 2 is 0, and here's 0. And of course you're going to be doing for the other ones, like 2 times 2 is 4, minus 3 is going to go to 1, 2 times minus 3 is minus 6 minus 0 is minus 6, 2 times minus 5 is minus 10 minus minus 3 is going to give you minus 7. Similarly, we're going to be doing turning this into a 0. So here's 1, here's minus 3. So 3 times 1 plus minus 3 is going to give you 0. That's why I say 3 row 1 plus row 4. All of that multiplied by 3, each of these elements, and add to each of these elements, and you're going to end up with this. Now, what we did here, we turn all of that to 0. So I'm going to proceed by turning this one into a 0. Okay, so how we can do this, and we can say, but this also can be divided. Wherever you can see that these can be divided by a number that divides everything, okay, or the factor of it. So 6 divided by 2 is 3, 2 divided by 2 is 1, minus 4 divided by 2 is minus 2. And then turning that into 0, that's not quite difficult, is 2 minus 2 row 3. Row, you can say row 2 minus 6 row 3 if you want. So 6 minus 6 times 1 is 0, and here's 0. 6 times 2 is 12, 12 minus 6 is going to be, 12 minus 36, because 6 times 6 is 36. That's going to give you 38. And then also you have minus 4 minus 6 times row 3, 6 times minus 7 is minus 42. So minus 4 minus 42 is going to give you 38. You do these ones as well with this, and you're going to end up with this. 0, 0, 64, 64. And then you divide by 64, you divide by 38 to turn these into 1. So here's the reduced, the row echelon form of the matrix. And of course you can check from here itself, we have 3 leading columns, and the dimension of the space range of T is 3. Now you can turn that into its fully reduced row echelon form by performing further operations. So what I've done here, 3 row 1 minus 2 row 2 is going to give you this one, and then you take the second row here, row 2 minus row 3 is going to turn into this, and then you divide wherever you can see, you can divide, like turn this into 1, 1 0 0 1. So divide by 3, and here's the final reduced row echelon form. Now for this one, this matrix here will help you to answer the other parts of the questions, which will come in a moment. Just bear with me. Okay, now we're going to try to find a basis for the null space. So to do that, I'm going to take the fully reduced row echelon form of the matrix, okay, which I have nicely done there. So we copy that down. Then you multiply by a vector x1, x2, x3, x4. Say 0, 0, 0, 0. So what do we make out of this? X times 1 is x1, sorry, minus 11 over 3, x3, minus 11 over 3, x4 is equal to 0. Therefore, x1 is equal to 11 over 3 x3 plus 11 over 3 x4. Moving on to this one here, this is x2. So we have then x2 and minus x4 is equal to 0. That means x2 is equal to x4. Then x3 plus x4 is equal to 0. Therefore, x3 is going to be equal to minus x4. Now, that's my free variable. Okay, so this is the only one that's got a 0 here. So we're going to say let x4 is equal to t. Now, this is where it gets interesting. If x4 is equal to t, what is going to happen? x3 is equal to minus x4. Therefore, x3 is going to be equal to minus t. Now, also x2 is equal to x4, and also therefore x2 is going to be equal to t, because it is equal to x4 and x4 is equal to t. Right, and what about this? What about x1? So x1 is equal to then 11 over 3 x3, that's 11 over 3. x3 is minus t, so that's going to become minus t, then plus 11 over 3t, plus 11 over 3t. And that's going to be equal to 0. So what do we have? x1 is equal to 0. So a basis for the null space, okay, the null space of t, okay, of t is going to be equal to this vector here. x1 0, x2 is t, so we can put t outside, and then 1, because 1 times t is t. x3 minus x4, that is x3 is minus t, so we can say minus 1, because minus 1 times t is minus t. Then we have x4, we said that x4 is equal to 1 t, x4 is equal to t. So here is the basis for the null space. So that's the second part of the question. So we're going to come to the third part in a moment. Okay, for the third part, we are told that it is given that x satisfies the following equation. Here we go. This is part of the question. We are told that x satisfies this equation. So this equation. Also, we are given the fact that h times some vector here, all right, is equal to this. So this could be equal to that. So these two are the same because they give the same result. However, what is it follows when we have a situation like this? It follows that a general solution to this problem will be given by, then, let me just call it x if you want, the general solution, and in this circumstance it's going to be given by this vector here, alright, 1 minus 3 1 minus 2, plus the vector in the null space. Remember, we had a vector in the null space. This was the nullity, null space. So the null space vector, the parameter was t. You may leave the parameter as t if you want. So t times the vector in the null space. So we have then 0, 1, minus 1, 1. So if you multiply this, this is what you end up with. You have 1 minus 3 plus t, and then 1 minus t, also minus 2 plus t. And of course what we're looking for is the modulus of x. Okay, and therefore what's the modulus of x? We can build up an equation here. To the square is going to be equal to let's say then 1 to the square plus minus 3 plus t to the square plus 1 minus t to the square plus minus 2 plus t to the square. So when you do that, should be able to get 3 t square, sorry my handwriting here, 3t square minus 12t minus 15 is equal to 0. So if you simplify that, you're going to end up with t square minus 4t minus 5 is equal to 0. So solving that, I've equated this to 0 here. So t and then t, and you've got 5 and you've got 1. So minus 4, so that should then be there. T is equal to minus 1, t is equal to 5. Now we're going to use these two values. We're going to use these values by substituting them in here to be able to obtain the vector x. And you will observe that the vector x, whether you're going to take minus 1 or you're going to take 5, you place in here, you will always end up with, here it's going to be 1, minus 4, 2, and then 3. Minus 3. This is when t is equal to minus 1. But if you, I'm sorry, I made a mistake. But if you replace t, okay, let's say when t is equal to 5, what's going to happen? What I meant by that is, I'm going to tell you in a moment. If you take 5, it's going to get 1, 5 minus 3 is 2, 5 minus, 1 minus 5 is minus 4. It's not, so 5, t is 5. 5 minus 5 plus 1 minus 4. Then 5 minus 2 is 3. As you can see, 1, 2, 4, 3, 1, 2, 4, 3. So if you take these, any of these vectors, and you try to find their magnitude, okay, that's what we're trying to find the magnitude of the vector x. You're going to do the square root of these numbers. So what, you take any of these vectors, you're going to get the same. So 1 square plus, let us say 2 square if you want, plus minus 4 to the square, that's 4 square anyway, plus 3 square. And that's going to give you the square root of 30. So that's the magnitude of x as required. However, you can test if you take any of those two vectors, alright, and you take the original matrix, that is this matrix given here, alright, multiply by any of those vectors, any of those two vectors here, you should be able to get this answer. And that actually satisfies the whole equation, alright, which means that your answer is correct. Okay, so here we go for this. Quite a long question. There's quite a lot of calculations, especially when it comes to the row-echelon form. That takes a lot of time. I wish they could allow you to use the calculator to find the row-echelon form. There is the TI Texas 84 instrument calculator, TI-84 CE plus or something. If you just input the matrix there, they're going to give you the row-echelon form. That's going to save time. And using the row-echelon form, it's just for you to do these calculations and get the answers that they are looking for. Anyway, that's not yet allowed by Cambridge, and let's hope in the future it will be. So beautiful answer here. Take care.